is inverse trigonometric functions. We are looking at finding the value of inverse trigonometric expressions with and without a calculator, and also sketching the parent graph of the sixth inverse trigonometric function. We have here a basic sine function. We've already seen this one from the previous videos. So for a function to have an inverse function, it must be one-to-one. That is, it needs or it must pass the horizontal line test. So in the figure below, it is obvious that this function does not pass the test or does not pass the horizontal line test because different x values yield to the same y value. So for example, this dot right here, it's negative, or this point is negative pi comma 0. And it also has another one here, pi comma 0. So you have two different x values, but the y values are the same. So if you take a look at the entire graph, it looks like it does not pass the horizontal line test. Therefore, it does not have an inverse function. But if we only look at the black portion, so if you only look at this portion, this black portion is from negative pi over 2 to pi over 2 with a range of negative 1 to 1. So if we only look at that portion, it looks like it passed the horizontal line test. Yeah, it's a 1 to 1. So on the restricted domain, so when in this section, so if x is from negative pi over 2 to pi over 2, it looks like the sine function has a unique inverse function called the inverse sine function. So there are two ways to write that down. So you can write this down at y equals arc sine of x. Yeah, you can see it's read as arc sine of x, or in the calculator, it looks like this one. Yeah. Sine inverse of x. So you can, these are interchangeable. So today's lesson is all about finding the inverse function with and without a calculator. So we're going to try without the calculator first, of course, using the unit circle. So here it is. So find the exact value of each expression without using a calculator. So remember, this is an inverse function. So arc sine of 1/2. So sine functions is, if you look at the unit circle and we're looking at sine function, we're looking at the y coordinate, right? The y value. So if you're looking at that one, that's the y coordinate. So that's the ratio. So what we're looking at here is we're trying to find the angle. So what angle, what radian in the unit circle that has a y value of 1/2? So if we, because this is an inverse, so sine of what angle equals 1/2. So we're looking for the radian, the angle that has a y coordinate of 1/2. And because we're looking at sine functions, and sine function has a restriction. Yep, we have a restriction right over here. So we're looking at only this section right over here. So this is where pi over 2 is, and this is where negative pi over 2. So we're looking at the angles that belong to this section only. So of course, we have 0 right over here. So let's take a look at the unit circle. So here's the unit circle. So we're only looking at this section right over here, all the way to this section, or technically this section all the way to that section. But since this is not one full circle, this is no longer a 3 pi over 2. So if we're looking at that section only, this section only, we are now calling this as negative pi over 2. We're calling this one as negative pi over 6. This is negative pi over 4. And this is negative pi over 3. The coordinates are still the same, doesn't change, but the radian changes, and of course, the degrees changes as well. But we're not looking at the degrees in particular, we're looking at the radian. So remember, this is negative pi over 6, negative pi over 4, and then this is negative pi over 3. So back to our problem, what angle in this section has a y coordinate of, or has a ratio of 1/2? And that's right over here. And the answer is pi over 6. So our answer here is pi over 6. So this one, I think this one is easy. As a y value of 0 is 0 radian. And then negative what? Square root, negative square root of 3 over 2. So let's take a look. Now, remember, there's two of them. We have here square root of 3, negative square root of 3 over 2. I also have a negative square root of 3 over 2 in here. But since we're looking at sine functions, I'm only looking at this section, so I don't care about this section at all. So I'm looking at this right over here. But the radian is not pi over 3, it's negative pi over 3. So our answer is negative pi over 3. Okay? Sketch the graph of the function y equals arc sine of x by hand. So remember now, the y value in this case is the angle, and then the x value is the ratio. So let's take a look. So x and y. So I'm going to start with nice y values, or let's start with the angle. So the angle is from negative pi over 2, followed by negative pi over 6, 0, pi over 6, and pi over 2. Why am I skipping pi over 3? Why am I skipping pi over 4? I'm skipping them because they don't have, remember, we're doing it by hand, and they don't have nice y coordinate. They have square root of 3, square root of 2, so I'm skipping those. So I'm only using the nice values, which is for negative pi over 2, the y value, y coordinate is negative 1, negative 1/2, 0, 1/2, and 1. And hopefully you've memorized them by now. So let's take a look. Let's graph it. So an x of negative 1. So let's do call this one negative 1, and then this is positive 1. And this is pi over 2. That's pi. Negative pi over 2. And then this is negative pi. That's graphed. So negative 1, negative pi over 2. So again, same thing. This is negative pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So negative 1/2, negative pi over 6, 0, 0, 1/2, and pi over 6, and then 1 and pi over 2. So this is the graph. No arrow. Oh, it's not supposed to be a line. There you go. There's no arrow, no arrows here, because remember, we have a restriction that it has to be from negative pi over 2 to pi over 2 only. Okay, so let's take a look at example number 3. So for example number 3 is a combination of all the trig functions except the sine functions. So we already did sine functions above. So the problem in here is that every function has different restriction. So for sine function, our restriction was, let me take a look. For the sine function, our restriction from pi, negative pi over 2 to pi over 2 But for cosine function, it looks like it's different. It's from 0 to pi. Yeah, so for a cosine function to have an inverse, we need to restrict from on this interval. So let's take a look at all of this. So this is all the restriction. So for sine function, our range is that way, negative pi over 2 to pi over 2. For cosine function, it looks like it's from 0 to pi. For tangent, it's this way. For cotangent, it's that way. For secant is this way. For cosecant, it's this way. So let's summarize it. It looks like arcsine, cosecant, the inverse, yeah? And tangent is the same. And then it looks like cosine, secant, yeah. So arc sec, arc cosine, and then arc cotangent are the same. Okay, there you go. So let's solve. So for cosine, we're not looking at the y coordinate, we're looking at the x coordinate. So cosine of angle equals square root of 3 over 2. So cosine is restricted on this one. So in this section, in the unit circle, what angle, what radian has an x coordinate of square root of 3 over 2? So let's take a look. So this is the section we're looking for. And square root of 3 over 2 is right over here. So it looks like pi over 6 is the answer again. So we have pi over 6. So for tangent, tangent has restriction. So tangent of what angle? 0. So has an x coordinate of 0. So in this section right over here, x coordinate of 0 is tangent, not x coordinate. Sorry. So for tangent, we're looking at, okay, so for cosine, we're looking at x. And then for tangent, we're looking at y over x. Y over x. So what is y divided by x equals 0? Yeah. So the only way to get a 0 is if you have a 0 on top. So it has a y value of 0. So tangent y value. So 0 divided by 1 is 0. So the answer is 0. Right of you. Oh, sorry. Yeah. 0 right there. Okay. Now for cotangent. Oh, by the way, you can also use this values right over here. I think it's also easier if you use this one. But again, in the test, you need the unit circle. But let's try using this one. So I'm looking at cotangent, right? So I'm looking at the cotangent, and cotangent has that restriction. So cotangent, so if tangent is y over x, so tangent is x over y. So in order for it to have an answer of 0, again, it must have a 0 on top. So it has to have an x value of 0. Or if I look at the cotangent over here, cotangent right over here, value 0 is for pi over 2. So the answer for this is pi over 2. Or if I look at the unit circle, it is x over y. Okay, for second is the inverse of cosine. So if cosine is x, finding x, second is finding 1 over x. So what is 1 divided by x equals 2? So second of something equals 2. And let's take a look at this one. So second is right over here. 2 is pi over 3. So second is pi over 3. And then second is in that restriction. But how do I use the unit circle to find that? So this is 1 over x. So we're trying to find something 1 divided by x. Yeah, so we're looking at y 1 over x equals 2. So what is 1 divided by x is equal to 2? What is x? Does that make sense? Yes, so in the pi over 3 right over here, x must be 1/2. Yeah, so I am hoping that that is making sense. Okay, so let us technically multiply x on both sides. You have, so you have 1 equals 2x divided by 2. So we're looking at x equals 1/2. So we're looking at what angle has an x of 1/2. Okay, for cosecant, we're looking at this section. Cosecant is like sine function. So we're looking at negative a square root of 2. So I'm looking at cosecant right over here. Doesn't have negative, of course. They're all positive values over here. So cosecant is right over here. Yeah. So square root of a negative square root of 2 is at the 5 pi over 4. But let's take a look at this one. So 5 pi over 4. Yeah. Because remember now, cosecant is in this section right over here. So we're not really looking at that 5 pi over 4 on here. We're actually looking at this one over here, this section. Because our restriction for cosecant is from negative pi over 2 to 2. So we're looking at this one. Yeah. And cosecant is 1 over y. So we're looking at this one right over here, negative pi over 2. We're looking at this y value. So if you want to solve it, by the way, the answer is negative pi over 4. But if you want to look at how did I know? So 1 over sine is for cosecant. That's technically 1 over y. So 1 over 2 over 2 plus y times 2. That is negative 2 over square root of 2. And then, of course, you know, negative 2 square root of 2 divided by 2. Cancel. And you get that one. So we're gonna have to find that at a negative pi over 4. Okay. So the rest of it is just a calculator. So you're gonna use your calculator to find the value. So in the calculator, you'll find this one and you'll get that number. And then in the calculator, just find that trig function button. And then this one is, again, 2. That's undefined. Okay, I'm hoping that that's making sense. If you have any question, please let me know. And then I'm going to show you a quick example of how I will do number 13. So again, this one is an angle. This one is the ratio. So we're looking at cosine. So we're looking at nice x values, and cosine has a restriction. So for cosine functions, we're looking at a restriction of from 0 to pi. Okay, so we're gonna do 0, pi over 3, pi over 2, 2 pi over 3, and pi. And then 1, 0, negative 1/2, negative 1. So these are the x coordinate of each of these pi radian. But why am I looking at the x coordinate only? Because I'm looking at cosine. Yeah. So remember, sine is looking for y values or y coordinate, cosine looking for x, tangent looking for y over x, and then cosecant is 1 over y, secant is 1 over x, and then cotangent is looking at x over y. Let me know if you have any questions, and I'll see you in the next video.